Hello! This video offers a summary of the methods and results obtained through the development and testing of an ultrasonic sensor intended for use on a European scientific mission. One possible area of study on Europa is its oceans and its composition. To analyze this ocean, a current profiler using an ultrasonic sensor could be used. With this goal in mind, this project aimed to obtain distance measurements between the sensor and target object. To calculate these distances, using the equations seen here, first, the phase shift of the received signal has to be calculated. To get this phase shift, an ultrasonic sensor was built and hooked up to an oscilloscope to read the resultant signal. This final ultrasonic circuit can be seen here. On this side, we can see the circuitry to support the transmitter transducer. It includes a MAX 232N integrated circuit that allows the final peak-to-peak voltage to increase after the initial lower 5 volts is supplied. This component was supported by these 5 external 1 microfarad capacitors. Next, we have the transmitter transducer, which outputs the 40 kHz signal, followed by the receiver transducer, that is designed to only produce a signal when detecting that high-frequency reflected signal. And finally, we see the circuitry to help process that return signal. We can see the LM324N op-amp that is used to increase the amplitude of the weaker received signal so that it can be analyzed on the oscilloscope. This half of the circuit also made use of 3 potentiometers and additional resistors. Before starting the distance measuring with the student-made ultrasonic sensor, the experimental setup used in this lab was tested for functionality using an existing Arduino ultrasonic sensor, seen set up here. The sensor was attached to a signal generator and an oscilloscope to verify that a signal could be generated without an external microcontroller and that an accurate reading could be made by the oscilloscope, an example of which we can see here. Knowing that the signal generator and oscilloscope would be sufficient for signal analysis, the distance measuring experiment was set up to test the student-made ultrasonic sensor. We can see in this footage the signal generator outputting an approximate 40 kHz signal, an initial oscilloscope reading of the signals, and the voltage generator used to supply that 5 volts to the circuit. An interesting observation from this experiment was that even before supplying a signal or voltage, the receiver transducer was able to detect a signal from various noise sources in the room. Once a signal was applied, we can see this noise increase, even though the transmitter receiver wasn't yet being aimed at a target object. To test the ability of the transducers to measure distances, a 40 kHz signal was applied and measured from the transducers using the oscilloscope probes. We can see that as the distance between the transducers changed, the plotted signals experienced a phase shift relative to each other. In measuring the time difference between these signals at these different distances, the corresponding phase shifts, times of flight, and thereby distances could be calculated. This table offers a summary of these values. To analyze the accuracy of this sensor, a ruler was placed next to the transducers during the experiment to measure the actual distances. This table here shows the resulting percent errors between the actual and calculated distances using this sensor. As we can see, as the distance increased, the sensor became less accurate at measuring distances. One possible reason for this is attenuation of the signal over those larger distances. It should also be noted, however, that the circuit was found to be particularly sensitive to physical vibrations, which may have also caused errors in the reading. We can see in this footage how the signal changes and becomes unstable when the circuit components are touched. To further improve the results, this experiment could have gathered its time change values from numerically sampled data recorded by the oscilloscope, rather than being taken from the plots directly. Thank you.